Welcome to Apache Karaf Essentials. I'm Jamie Goodyear. Today we're going to work with how we actually build bundles for Karaf using the Maven Bundle Plugin. Up next. Okay, to dig into how we use the Maven Bundle Plugin, we're going to need a little project for examples. So we're going to use the Karaf bundle archetype to generate a small project and then expand it a little bit so we have some packages to work with. We've already done the work to make the code, so you'll find in the show notes below a link to our repo so you can follow along. For illustrative purposes, I've made a small diagram here to show what was made in this project. The important part is that we'll have a directory created with a POM file and a set of source code. The POM file shape will contain the coordinates, the standard part you'll see in any POM, a set of properties, some dependencies, and a build section. In that build section will be the Maven Bundle Plugin. In this generated code that's made by Archetype, it's just going to give you a small package that will include an activator. We've expanded it to also include a package for APIs, our implementation, where our activator will live, and utils and a command. What we're doing here is we are setting up a small service by API, its implementation, some utility classes, you'll find a utilities package, and a command package which is used by Karaf for us to exercise that service. Let's take a look at the code. All right, let's take a look at what we have generated here. We have a POM file which will describe our project and a set of source code. Let's take a very quick look at the code that we've written out for us here. We have an API, which is going to be our service with a pair of methods, with the important one for us right now being make XML of an input string that gives us back the XML string. We have an implementation, which is going to have an endpoint implementing our service that's going to convert that input string to something that looks like XML using a utility class, which literally just wraps our input with some tags. The activator is present. It's one that was generated by the archetype, which will just print out when we start our bundle and stop the bundle. We also have a Karaf command. We have a video on how these work. Effectively, it's just going to give us a command line tool to be able to exercise our service. Let's go back to the POM file. So we can see our basic coordinates have been set up where we have our com Sapphire bundle demo. We give it an artifact name of sample and packaging of bundle. This is important. This must say bundle if you want to be able to take that jar, make it into an OSGi bundle. We set a name and a description for this project. Our properties are set up. We are aligning with Karaf 4.4.7 and the versions of software it support. All of the dependencies we need, most of these are for setting up Karaf commands, so we have connections to OSGi and annotations to use it along for SCR. And we have a commented out jar that we'll use a little later on for the advanced usage of the plugin. So let's dig in finally to the Maven Bundle Plugin. Let's expand this so we see a little better. Let's start off with the basic elements here. We set up in the configuration a set of instructions that it will use to build the jar into your bundle. Among this, we'll set a symbolic name, which in our case, we're going to just take our artifact name. If we don't do this, we'll end up with a very difficult to follow name, which would be like group ID artifact name. This is a lot easier if you can call it something like our service, so you know exactly what it is when you're looking at Karaf console. We set a bundle version, use semantic versioning for this. This way it works best in OSGi, we need to use that. That way we're able to say, hey, here's our service version 1.0.0 or 1.0.1. It makes it clear what we are running. We can tell the system where the bundle activator lives. This is something that will be pre-populated for you if you use the archetype. You do not have to have an activator implemented directly. You can see our video on how activators work, and also our Blueprint and SCR videos. If you're using Blueprint or SCR, you can avoid the activation step because those are being wired and instantiated separately from when we just load it directly in and say, use the activator to start your bundle. We also have a Karaf commands. This is specific to Apache Karaf, and this is telling it where to find any command classes we have for interacting with our software. So this is something just for this demo, but I tend to use Karaf commands as a very easy way to test on our console. Okay, now let's get into the package bundle space. This is, let's dive into bundle space. We have a deep dive video on the topic, so I suggest you see that after this video. Now let's dive in. we have three elements that make up how we interact our bundle with the runtime. I'm going to use a diagram here to explain at a higher level what's going on. When we build our bundle, we're going to start with the green one here. We will have our manifest file, a set of packages that we don't want the world to see. I have a little X next to it to say, hey, these are hidden from the rest of the world. And some packages here that may need to export something, say our API or service, to the rest of the system. Other bundles may need that particular export for it to run. So the way we've illustrated is, say, package foo in our bundle A exports the foo package. And on bundle B, there is a package that needs the import of that foo package for it to run. It needs it for its runtime. Think of it as class path. So when bundle B starts, it says, hey, is foo available? And if it is, it'll be wired together and now they can run. The way we express that is going to be through our plugin directives, these instructions. When we're exporting our API, we want other bundles to be able to use the API. We will say, hey, here's our ComSaver bundle demo API package and everything inside of it. And at our version, export that to the runtime. Now, other bundles that need it can be wired to that one. Our private package says that anything else that we have here inside of our project, we don't want the rest of the runtime to be aware of it. So in our case, that would be, I don't want someone to have a dependency on my implementation classes. I don't want them to have a dependency on my utility classes, because the utility is not something I'm providing as a service to someone else. I'm having this for my own internal use. Now, in the case of importing, say if I was building a bundle and I need to use a package that someone else has built, that's when I would have listed in here. I need to have access to, say, org apache.logging, something like that, and I need to gain access to that package at a particular version range, so that way I can use it. Is this section here that we do all that work to say, in the runtime, this is the relationships I have between my bundle and the runtime, and this is what needs to be satisfied. So this is going to be the area you're going to be coming back to time and time again whenever you need to do updates to your application to say, this is what I support, I use this version range of these dependencies, and everything else, this is what I provide, and this is what I don't want the rest of the world to see. When we use start import, what we're telling the plugin to do is to take a look at all of our dependencies we've defined and their versions, and we're saying, hey, optimistically put this together as our imports for our manifest. So in our case, it's going to see things like OSGi and a shell and annotations, and it'll create imports for those particular packages and give a very optimistic range for those to be imported. Annotations, for example, will say, hey, import annotation between versions 1.4 up to but not including version 2. We can be more precise, however. We could go in and set up a particular package and say, hey, I want leucine for some reason between versions 1.3 and 2.0. And if we said, oh, no, we actually need that to be up to version 1.5 as your max, you can set things up like that. Under our various documentation, you can find out all about how you can say, I want to have hard limits of version A up to version B, inclusive, non-inclusive. There's a whole expressive syntax we have for that. We can also set things such as resolution. We can set it to be optional if we say that we know there's a particular package that we don't absolutely positively need to have. That tends to be a case of a transitive dependency you need to have for one of the other packages. You know you're not using that, you've tested out your code, you're not using it, it is something that does not absolutely need to be present for your code to work. This might be an option for you, but this is a edge case because you're starting to go against the spirit of an OSGi system in which our contracts are telling our bundles if you are resolved and you're instantiated, you have everything you need to run and not going to end up hitting a class not found at runtime. So if you do opt to use this as a way to get around a particular package, be aware that if your code does look for that, you could end up in that not found situation. Okay, let's take a look at the project and build it and see what happens when we run this in Karaf. So we're going to just use Maven clean install and it will build our bundle. And now we'll deploy it into a Karaf. So we're going to start Karaf in a separate terminal here. And for this particular project, since we're using SCR, we are going to install the SCR feature. And now we will install our bundle, which is going to be our coordinates to ComSaver bundle demo sample 100 snapshot. Okay, so we have a bundle ID of 57, and currently we're just in an install state. We can use the headers command to take a look at what was generated by the Maven Bundle plugin. This is going to show to us what's inside of our manifest. So we can start off with the basic preamble that, yep, we are here in OSGi bundle. We can see that a Karaf command has been populated. We use this in Karaf internally. We have our basic information about the bundle. So there's an activator location. It knows where to find it. There's the description, which it actually got from the POM file. So you'll see at the beginning of a POM file, we had gave it a name and a description, and that has been populated into here. And the version of our system, we can see our symbolic name that we set. Let's take a little look at what else we've got set up here. We can see that the plugin has set up some of the things that this bundle can provide. It has our service is a capability of this bundle, and it tells us about things that we need from the system. It needs to have OSGi component between versions 1.4 up to version 2 available, that we use that inside for our command and for SCR. We also have Java 17 as a base level. Now, the reason that shows up in here is that in our POM file, we had set up a extra build portion here that said that our source target was version 17, so it was aware of it and it set it appropriately. In here, we also see the export and import packages. You'll notice it doesn't say anything about what we kept private because we don't need anyone to know about that in the system for the runtime. So our exports will show our API package at version 1.00 snapshot has been made available. And on our imports, we can see that we're actually picking up a number of things from Java, which is just going to come straight from the class path of Karaf. And it's also picking up from the environment, things we need for the Karaf shell, and from our OSGi framework. Curiously, you'll see here that we have the COM Savor Bundle Demo API, and that's not satisfied. Well, it's because nothing else in the system is providing that, and it is an okay practice for you to export and import your own API. That is okay to do. So let us start this bundle. And we'll see that the activator did its printout of starting the bundle, and if we do our list, we'll see it's active. Since we have included a command, we are going to just show that we can pass in some text and we get back a element for an XML string. Okay, let's go back to our POM file. And we'll collapse this piece here so we can see more in here. Let's take a look at some more advanced things we can do inside of the plugin configuration. We have in here an embed dependency section. What we are going towards here is that imagine we wanted to include something like LangChain4j, which is not purely well made for OSGi. It has a lot of dependencies that are not OSGi friendly. You can use a tag here that says, I want to embed this library inside of my jar. So what this is going to do is say, I'm going to look for anything that's been scoped, compile, or runtime, and I'm just going to add that inside and make something of an Uber jar. Now, obviously, we may not want everything that we are setting as compile runtime, so we can target it to the artifact ID and say, I want that embedded. To go a little bit further, we can also say, I want the transitive dependencies of anything I'm embedding to also be included. In this way, we can take something, say if it was a JDBC driver or something else like that, and we don't want to distribute it. It may not have a nice OSGi service that you can use. This is a way we can put it inside of this particular jar so we can use it. Now, once we have it in here, the next thing you're going to want to do is take a look at the bundle class path. In OSGi, we want to be able to take everything from our environment. That's why we're using our imports and exports. This is, the entire organization. Sometimes, though, we do hit that roadblock where we have that special jar that has a very special reason to be there, and it's not OSGi friendly. What we can do here is that since we've embedded it now in a jar, we can set up our class path dependencies, and we can manually manage it there by ordering our jars in the localized bundle class path. It's not the perfect solution. It's not the spirit of what we want to do, but it is a way for us to work around that problem if it occurs. Okay, I think we have now enough information for you to start using the Maven Bundle plugin successfully. There are more advanced use cases and more functionality that you can explore, a lot around using OBR and deploying your bundles to repositories. With that being said, this is enough to get you started for about 90% of cases. The documentation is online. You can get it from Apache Felix, and there's more documentation at Apache Karaf. Please seek those sources, and of course, in the comments down below, if you have questions, ask them away, and we'll see if we can help answer them. And with that, please remember to like, subscribe to our channel, and hit the notification bell. Have a great day. Cheers.